All right, 4.1 talks about or begins talking about inverse functions. Okay, now before we go and define inverse, right? Let's talk just about what a function is, right? Now, a function is basically an equation in two variables, right? And with this equation in two variables, right, for each input, which we say are the x values, there is exactly one output y. Okay, now with that in mind, right, we have two things we have to describe. One is the domain of a function, which is your set of x values. And second is the range of a function, which is the set, the set of y values. Okay, so you've dealt with linear functions and all that before. So just know and understand that it's an equation in two variables, generally x and y, right? Such that for every input, there is exactly one output. All right. Now, the inverse of a function is a function or relation that undoes the work of another function or relation. Now, the input of a relation ends up being the same as the output of its inverse, and the domain of the function becomes the range of the inverse and vice versa. Okay, so when we go and look at these, we say an inverse is a function or relation that undoes the work of another function. Okay, if a function adds 3, then its inverse, right, does the opposite, which is subtracts 3. Now, anytime we talk about a function, if I give you a function, I would say f of x. That is the function. When we talk about the inverse f of x of a function, you'll see a little exponent -1 up at the top, and you would say the inverse function of f. Okay? Now, the domain of a function is the range of its inverse. So the inputs of the function become the outputs of the inverse. Okay? Then the range of a function is the domain of its inverse. And I'll explain this a little more when it comes down to examples. All right. So if I give you a function, right, your input values are x, then your output values are y. When we have an inverse function, now your input becomes your previous y values, and your outputs are now your previous x values. Okay, now, when we do that, we're not going to keep them as y comma x. We just think that right now. So the first part of this lesson is if you're given a function, right, and in this example, they give us this function here, right? How do we find the inverse of the function? Okay, now, a lot of people will say and understand that anytime we have f of x, that is no different than just saying y. So a lot of times we'll give you f of x equals, which means the same as y equals. These are, very compatible. All right, so the first thing we're going to do is rewrite this function as y equals x plus 3. Then what we do next is we are going to change the y to an x and the x to a y and finish the rest of the expression. Now, all I'm going to do, right? So a lot of times I just like to write this as y plus 3 equals x. So all I did was copy this here and that there. And now all I'm going to do is solve for y. And how do I do that? Subtract 3 from both sides, and y would equal, those cancel out, x minus 3. Okay, now my final answer, because this is the inverse of that function, right? Instead of f of x now, we're going to use this represents the inverse of f of x, which would be x minus 3. Okay, so the inverse of this function is x minus 3. Okay, so to find the inverse of any function, take the original equation and solve for the input variable. Okay. So now for this next example, they're going to have you approach it slightly differently than the one up above, right? What they're going to say is, we read this as function p, so this here represents your output, this here represents your input. So we're going to write this as our output equals 2 times our input plus 3. Now what they want you to do, okay, is solve this function for the input value. Because remember, right, if you have your function, it's always your input comma your output, right? But now we're switching it to output comma your input. So what we're going to do now, real quick, is solve this equation for s. So I'm going to subtract 3. Now, let me go back. Because it's easier to move things from left to right, some people will just write it like this. And now, what do I do to solve for s? Subtract 3. I get 2s equals p minus 3. Then I'm going to divide both sides by 2, and I get s equals p minus 3 over 2. Now, with this, what you have to understand is now in the inverse function, right? This is now my output, and p is now my input. So when I write function notation, my output s with respect to my input p is equal to p minus 3 all over 2. Okay, so you're basically rewriting the function by flip-flopping the input and the output, and write your final answer in function notation. Okay, so number 7, okay, the function c of f, right, converts degrees to Fahrenheit, all right, to degrees Celsius. Find the inverse of the function that converts degrees Celsius back to Fahrenheit. Show your work. Okay, so now this is more just like about it being a difficult equation to solve. But what we're going to do is we're going to write this as our output C equals 5/9 times my input Fahrenheit minus 32 degrees. Okay, so now what I'm going to do is take this equation and solve it for F. Okay, and it is a little more complicated to solve for F, but the first thing we're going to do is multiply both sides by my denominator 9. When I do that, right, it's going to give me 5 times f minus 32 equals, when I do 9 times c, it would be 9c. Now, to get rid of 5, I'm going to go ahead and divide both sides by 5, and that would leave me with, these 5's cancel out, f minus 32 equals 9/5 c. Now, I'm going to add 32, and f would equal 9/5 c plus 32. But now what you have to understand is this represents the inverse of the function. So now our output becomes Fahrenheit, and what we input is Celsius, and the formula that would work for this would be 9/5 c plus 32. And we are done. Okay, so you have to understand, now we're inputting. The difference is at the beginning, we knew the Fahrenheit, we would plug that in to find Celsius. Now we're going to be plugging in Celsius as our input to find the Fahrenheit. Okay. So now let's look at some checkpoint problems or practice problems. So if we want to find the inverse of a function, right? This is like that first example we did. All I would do is rewrite this as y equals x plus 12, right? So instead of f of x. So now we're going to flip-flop these variables. I'm going to move x over here, right? Y over here. So I'm going to have y plus 12 equals x. And now I'm going to solve for y. Subtract 12, right? And y equals x minus 12. So our final answer, the inverse of f of x, would be x minus 12. Okay. The next example, and again, I would probably try some of these on your own and then come back and check your answers. But in this case, right, x is going to become y. So y over 3 minus 2 equals f of x now becomes my x. So now the first step in solving for y now, add 2 to both sides. Y over 3 equals x plus 2. Now I'm going to go ahead. How do I get rid of this denominator? I'm going to multiply everything in this equation by 3. 3 is eliminated here, and I get y equals 3 times x is 3x. 3 times 2 is plus 6. So the inverse of f of x is 3x plus 6. Okay. So now the next one, again, this gets replaced with x, this gets replaced with y. So 2y plus 12 is equal to x. Now my first step in solving for y here is subtract 12 from both sides. I get 2y equals x minus 12. Now what am I going to do to everything? To get rid of 2, I would divide everything by 2. So y would be equal to x over 2, right, minus 6. And x over 2, remember, is the same as 1/2 times x. You can look at it either way. So the inverse of f of x would be 1/2 x minus 6. Okay. And the last one, again, this was y, it's going to become x. This was x, it becomes y. So 3y minus 4 equals f of x becomes just x. Now, add 4, 3y equals x plus 4. Now, I'm going to divide everything by 3. So you would get 1/3 x plus 4/3. Right? And we rewrite that as the inverse of x would be 1/3 x plus 4/3. Okay. Couple more down here real quick. All right. As you move on, these just get a little bit more difficult, right, in terms of solving. But again, x becomes y, f of x becomes x. So we're going to say 2y plus 3 all over 6 equals x. Now, the first step here is to multiply both sides by 6. So 2y plus 3 equals 6x. Now, I'm going to subtract 3. And 2y equals 6x minus 3. I'm going to go ahead and divide everything by 2. And y equals 3x minus 3 over 2. And leave it as it is. But then we write our final answer in inverse function notation. So f inverse of f is 3x minus 3/2. Okay, next one. Again, replace x with y. So we get 2/3 y plus 5 equals f of x becomes x. Now, I subtract 5. 2/3 y equals x minus 5. Now the first step I'm going to do here is multiply everything by the denominator, 3. And here I multiply everything in the equation. So 2y equals 3x minus 15. Now I'm going to go ahead and divide everything by 2. The y's or 2's cancel out, and the inverse of f of x would be 3 over 2x, or 3/2 x, minus 15 over 2. And that would be the inverse of the function. Okay, so over here, we're going to say 5y plus 15 equals x. This becomes this side, but x gets replaced with y. Now, I'm going to go ahead, subtract 15. I get 5y equals x minus 15. Now I'm going to divide everything here by 5. So y is equal to x over 5 minus 3. All right, how do we write our final answer? The inverse of f of x is equal to x over 5 minus 3. All right, over here, if I look, I'm going to do 5y minus 1 over 2 equals x. Now to solve for y here, first thing I'm going to do, multiply by 2, 5y minus 1 equals 2x. Now, add 1 to both sides, 5y equals 2x plus 1. Now, divide everything by 5. So, the inverse of f of x would be f inverse of x equals 2 over 5x plus 1/5. And we are done. Okay, so finding the inverse of a function is pretty straightforward if you understand how to solve for the variables. Okay, number 9. Function m of d below relates the miles Bob can drive his rental car and the number of dollars it will cost. It takes as input the number of dollars spent and returns it as output the number of miles. Okay, so write the equation that represents d of m. So what you're going to do is take this equation, right? And remember, we're going to write this as my output m equals, right? It's going to be 40 times d minus 35. Now what I'm going to do is I'm going to go ahead and solve this for d. So the first way, and I'll rewrite this as 40 times d minus 35 equals m. So all I did was take this side, write it here, and that there. So 40 is linked by multiplication, so I'm going to divide both sides by 40. D minus 35 equals m over 40. Now I can go ahead and add 35 to both sides. So I get d equals m over 40 plus 35. Now with that, all I'm going to do now is say my output value d with my input value m, right? So it's d of m equals m over 40 plus 35. So now anybody can take the value of m, input it to find the dollars owed at the end. Okay? So again, this is a little bit different than what we've been doing up, same concept, but rewriting it in a different way. Okay, the next one. the function a of h below relates the area of a triangle with a given base of 7 and the height of the triangle. It takes as input the height of a triangle and returns as output the area of the triangle. So you have this formula here. So our output right now is A equals, right, 7h over 2. So we're going to rewrite this as 7h over 2 equals A. And what we're going to do is solve this equation for h. So we multiply both sides by 2. 7h equals 2a. Now I can divide both sides by 7. H equals 2a over 7. So now anybody who wants to go ahead and find, right, the height of a triangle with, right, the area given, you basically can use the output h with an input area. So h of a equals 2a over 7. And that would be the inverse. Okay. So do me a favor, go ahead and try the quiz and text me your score.